Hi everyone, this is Soumyadi Paul, a mentor at Code Curdos and a software developer at Amazon, and welcome to day 5 of our system design series. Now today we will be learning about something called as distributed systems. Okay, so let us come. What is distributed systems? Let me write it here. Distributed systems. Okay. Now, what is it? Now, before we jump into distributed systems and what is it, let us first try to understand what is the requirement कि भाई ऐसी क्या ज़रूरत पड़ी that people invented this thing. Now, do you know that this, if you see the total amount of data, digital data that has been generated on this planet, 99% of data that has been generated on this planet has happened in just the last 10 years. 95% of data has been generated in the last 3%. 90%, sorry, in the last 5%. And 90% of data has been generated in the past 3 years. So the graph of data generation is literally an exponential graph. With every smaller amount of time being passed, huge difference of new data is coming up. Okay. And this is the problem. We are having too much of data, too much of data. With the onset of social media sites like Instagram, Facebook, Twitter, TikTok, YouTube, and then a lot of emailing sites and etc. We have too much of digital data. And now all of these digital data needs to be stored somewhere. There needs to be happening some operations, some calculations, some computations. You need to fetch them from somewhere. You need to store them somewhere. Too much of data. Obviously, one computer cannot handle so much of data, isn't it? Earlier, we used to store all the data in just one computer. But now that is not the case. For example, let's talk about Facebook. Facebook has billions and billions of terabytes of data. So many users, so many posts, so much of data. Is Facebook storing all the data in just one computer? No, right? It is not possible. It is just not possible physically. No such computer exists. So, a lot of years ago, in the late 1900s, when people were working with data and they saw that the amount of data being generated is being too much that they can store in a single computer. They cannot store in a single computer anymore. People were thinking, how can we store this data? And if we cannot store them in a single computer, how we will be doing computations on this data? That is when the concept of distributed systems came up. Distributed system means that multiple computers or servers, are connected over a network. Okay. And are used to solve a problem. Of either storage and or computation. Okay, either storage and or computation. Okay, either storage and or computation. Okay. Now, see, suppose you are a developer in the late 1900s, 1995, 1998, somewhat that region, somewhat that duration. You suddenly have, say, 100 GB to store. But you could, or say 1000 GB to store. But you could only store, say, 200 GB in a computer. That is a problem, isn't it? The actual storage was way less at that time, but I'm just giving an example. Okay, so you have 1000 GB to store. How can you store the entire data in one computer when the maximum capacity of a single computer is only 200 GB? Isn't it? And if you cannot store all of the data in a single computer, how can you do operations, computations on all the data? That is when Google's engineers came up with something called as distributed systems. They said that we will be storing data in multiple systems, in multiple computers, in multiple servers. Suppose you want to store 1000 GB and your single computer can only store up to 200 GB. Then we will obviously be taking 5 computers. We will have 5 different computers. This is computer 1, computer 2, computer 3, computer 4, and computer 5. All of these computers can communicate with each other. This C1 can communicate with C1, C3, C5, C4. C2 can communicate with C1, C5, C3, C4. C3 can communicate with C2, C1, C5, C4. C4 can communicate with everyone. C5 can also communicate with everyone. And all of this communication is happening over network calls. Okay. This communication is happening over network calls. Okay. This communication is happening over network calls. Okay. This communication is happening over network calls. So all of these computers are probably under the same LAN, local area network. They're communicating through each other. And they're all storing 200 GB of data. So that in total you can have 1000 GB of storage. Okay. This is called as distributed systems, where you distribute your data into multiple systems. You have 1000 GB. You cannot store all of them in a single computer. You distribute into multiple systems, multiple servers. Okay. This is called as distributed systems. And now suppose if you want to do some computations, again the same thing also happens in computations. You can run computations parallelly in all of these computers. C1 is running computations on the 200 GB of data stored inside itself. C2 is running computations on the 200 GB of data stored inside itself. C3 is running computations on the 200 GB of data stored inside itself. C4 is running computations on the 200 GB of data stored inside itself. And C5 is running computations on the 200 GB of data stored inside itself. Okay. And then there must be some algorithm, or there must be some supercomputer, their boss. Okay, this is their boss. Let me, the boss can be in the center. And the boss then collects the output of the computations from all these computers and combines them to provide the final outcome, the final output. Okay. So this is what we have. In today's world, distributed systems is widely used. Everywhere, whenever you store data in some online server, all these AWS, Azure, Google Cloud Platform, all these hosting platforms, or say GoDaddy, Hostinger, all these hosting platforms, or Google Drive, where you can either host your server or you can store some data like Dropbox, Google Drive. All of those platforms have storage devices, servers all over the world, so that they can store your data and all the data of all the customers in different parts of their servers, in different servers all across the world. So let's take an example of Google Drive. There might be billions of gigabytes or terabytes of data, so many customers. I myself am storing about 50 gigabyte of data, 50 GB of data in my Google Drive. Let's say there are 500 million customers, 500 million into 50 GB. Just imagine, say on an average, every person stores say 10 GB. Imagine the amount of data Google Drive needs to store. Google Drive distributes that data into multiple thousands and thousands of servers. Okay. And that is what is called as distributed systems. Okay. And there is one more thing called as a concept of redundancy. Redundancy, also known as replication. Okay. Now, what is this redundancy and replication? Now, when you're storing your device in a distributed, when you're storing your data in a distributed system, every server stores some data. Okay. What if that server is down temporarily due to some network problem, or due to some temporary crash, or due to some issues, whatever it can, the reason can be anything. Okay. Technical failures in hardware is very, very common. So what if that particular server fails? So now suppose I have C1, C2, C3, C4, C5, I have 1000 GB of data, and one of the servers fail, crash, it is down for some time. So now my system can access only 800 GB of data. Some 200 GB of data is not available, and that will create problem. Maybe a user wants to fetch some data, and the data that user wants to fetch is stored in that particular server, which is down right now. So that is why we have something called as a concept of redundancy or replication. Every server is replicated multiple times. Okay. Every server is replicated multiple number of times. Okay. Every server is replicated multiple number of times. Okay. So when every server is replicated multiple number of times, there may be 3 servers, 4 servers. Whenever we are storing our data into a particular server, that server is also copying its data into few other replication servers. So that by chance the main server goes down, there are some copies, there are some replication servers which can take its place and serve that same data. Okay. Now don't worry, we will learn about redundancy replication in a much more detailed manner. But this is a very important concept which actually works coupled with distributed systems. Okay. So that's it for today's video, and if you want to learn these concepts in a much more detailed manner, then do join Code Cardos, where you will be learning from mentors like me who work at big top-notch companies like Amazon, Google, Microsoft, etc. Okay, so see you all in the next video. Take care and keep practicing.